Today we are going to start up with our second session, and just a recap before we start, I will share my screen before we move on. So what we introduced before is the idea of the whole series and why we chose to introduce Excel and what we could use Excel for in Dynamo. The idea was to use an Excel sheet that we always have, and it's a QTO that you get from Process and Planning, where you have all your Revit elements and their SFP codes. So the idea was to use this document in Excel and apply it in our Revit drawings. So if I zoom in onto this drawing, for example, you will see that, for example, the doors and the interior walls are tagged with the SFP codes. And that's what we are trying to achieve. We are trying to link data from Excel into Revit through Dynamo and use it as an example. So today, and yes, last session's was just an example, and we are going to complete that in today's session.
So when you're working with Excel in Dynamo and in Revit, you're always building upon things. So we've got this tool for making lists that we are importing or exporting from Revit, and then we're using the data to attach these SFP codes to what it is that we're actually doing, right?
Exactly.
So it's very powerful in the sense that you can take information that is so readily available in a lot of other formats from Excel into Revit and Dynamo.
Yeah, and why not use some Excel sheets that we always have?
Yeah, exactly.
Make use of them in Revit and make our models smarter than usual. So we broke down the whole idea into 4 parts. We covered the first 2 parts in the last session, 10th of November. Just a recap before we start and move on to today's session. What we did was we created a parameter to input all our SFB codes in. And then after of course, in Revit and Dynamo, after we did that, we moved on and we exported all our doors into Excel, into our QTO, so that we can use it later to do some manual work and then move to the last script that will link all our data into Revit again, into that parameter that we created for the SFP codes. And then, of course, with that, we could always create schedules. We could, using this parameter, we could always tag. There are plenty of things to do, but that's the whole basic idea of things. So we will start today's session with the manual work and then move on to the last script to finish up this series. So Alex, could you move on and share your screen?
I will indeed. So what we're going to start with is that we're going to start with this here quantity takeoff that we've got, and we are going to take the data that we exported last time, this into our system. We've got the SFB codes here. You can see they are from Sigma, the pricing software we're using. So what we're going to match is just take the export that we have here in a column by itself. We're just going to copy it and start putting it to the doors and the types that we want. So I've got this size here, I've got the next size, and you can see the matches, how often we've got them. So that's how we're getting our pricing right. So yeah.
It's very important, this part, because this is the safest part, since you are manually doing it.
Yeah,
you can always do it the way you want and the way you think it matches. With the SFB codes, of course.
And especially for pricing units, right, there's going to be some alterations and there's going to be some differentials and some things that we can't really go in and say, oh, I look at my SFB codes, I see what I've got of data, and then I'm going to apply it so we can sort through it in Dynamo.
Definitely, yes.
So, there we go. I've now got matched my my door types with my my SFB code that they're matching to. I've also got a unit number here. It's not really relevant for right now, but it is, of course, relevant for when we're going to do our pricing.
Yeah.
Cool. I am going to save this here, and then I'm going to exit it, because when I need it from Dynamo, it's not going to read it. So I'm in this project that we were looking at last time, right, where we've got our different doors. You can see that they don't have the I clicked the tag. You can see that we've got the SFB code parameter here, and then we've also got our type mark, which is just what it's showing right now. So what I'm going to do is I'm going to take these instances and actually bring them into Dynamo, so I can set what I'm going to do. The last thing that we're going to do is we're going to set our parameter, or we're going to set the parameter. We're going to name the tags according to the SFB codes in the different types. So what I'm going to start with, I'm going to start from the start because I'm going to find my elements first, and then we can worry about the rest later. So I'm just going to scroll over here, and the first things we need to do is just get a categories node like we've done so many times. It's honestly one of my favorite nodes. We are doing doors, so we're taking doors here. I'm just quickly going to switch to manual.
Yeah, make sure it's on
otherwise it's going to go wrong. Yeah. You can see I have the doors here, and then I want all of my doors. I'm going to search for it over here. All elements of category. Yeah, we have it right here. So this is going to category tag to an element tag. This is going to give me all the different doors that are in this here project with their ID. I then need to type. I need to sort these, right, because some of them are the same type, some of them are grouped together. So yeah, I'm going to start with getting an element. Keep on typing away here. Element. Get parameter, because I want the type of them. I can't spell either. Get parameter value by name. Yeah. I've got my elements right here, and what I want to get is their type name. So this is the type that they have been put into Revit. They might be in the same family of categories because they're all indoors, but we want the
family type.
Yeah, parameter. Exactly. For doing that, I'm just going to put in a code block writing type because that's what I want. Oh, I need to make sure that this is written with a capital T. I'm run again, and then you can see that I've got all the different parameters, same as we did here before, but they now have the family name attached to it instead of just having the number and the ID. So this is an instance, this is the family. Cool. And then I'm going to list all of these, and we introduced a note last time called group by key. I'm going to use the same one today, group by key.
And meanwhile, while he gets the node, what this node basically does is it groups all of these elements by a key, and a key is something that is unique. And right now, because he got the type parameter, that parameter is always unique. So what we can do is use that node to organize and group everything by the type. That's what Alex is going to do now.
Indeed. So now we've got everything here, and you can see that I have everything here grouped together. And the wonderful thing about group by key is that it actually gives us a unique keys. So in the end, that we're getting our everything that we're looking for here.
It tells you which key is corresponding to which list, so it's easy for you to know what's happening within the node itself.
And this is actually it, isn't it? This is all of the elements that I'm going to need. So I have my, I'm going to freeze this here first. And all I need.
Yeah, okay. So I can move on and share.
So Nuhat's going to take over and show you how to get all the rest of the parameters that we're going to need up here. So we're going to need the parameter name and the value.
Yes. So starting off or continuing what Alex did, we can move on to the parameter name. Now the idea was to get this data and add it to our elements within the parameter that we created, which was SFB code. So what we can do now is we can use a code block again, and to do that you double click in space and then use quotations and write the name of the parameter, SFB code. And another parameter that I would like to add this to is type mark, because if I go to Revit, and I think I'm sharing the wrong screen, let me just share again. Sorry about that. So if I go to Revit, I hope you can see my screen right now. Right now, my doors are tagged with type mark. So I also want this data to go into type mark as well. So it's both the SFB code parameter and the type mark.
Because
parameter.
this is what you're going to use for your further development of your projects when you're making plans of what door is going to go here for the contractor to actually put. So the good thing about this is that we can prepare our tags both for tender, for everything by doing it like this, as well as we get the parameters we require for quantity takeoff.
Exactly. So in order to do that, in order to do it for both the SFB code and the type mark, I will just click enter. And then I'll add some quotations and write type mark because I want it to be added to both of these parameters. And then I'll just click somewhere out in space. Now I cannot use this code block to add both the parameters at the same time the way it is now. So the way to fix this, it's quite simple, and we've already spoken about this in the previous sessions. You just use list create.
Another favorite note.
Yes, this is quite fun because you can always add as much as you want, and you can always remove them back. So it's quite easy, quite convenient for our case right now. So I'm just going to input those two parameters here and create my own list. And if I run, just to see what's happening, I will get them both combined. And now I can use this to add it to my parameter name because I specified that these two parameters are the ones that I want to add the values to. So that part is done. And just one thing to mention, make sure that your element set parameter, if you right click and you go to lacing, make sure that it's set to longest. And I'll explain this in the end when we're done with all the inputs. But just to mention it from now, in case you're doing it live with us, it's important to have that. So we have the elements and we have the parameter names. We only need the values now. And this is where it gets interesting because this is where we actually use Excel again to import things back into Dynamo and add it into our parameters in Revit. So
remember last time we exported and now we're importing the same data, but in a different section. Sorted it manually and now we can line it out how we want it.
Exactly. So in order to get data from Excel, we use a very famous node called import Excel. And this is a default node. It's not from any package. And what this node needs right now, if I zoom in, it has the file as an input and then the sheet name. And then these two we can ignore. It doesn't matter. But these two inputs are the ones that we need to have. So file, which Excel file do I want this node to read? And in order to get that and to specify my file, I'll just write file path. So first we identify the path of our file. And then we use another node called file from path. And the reason why we're doing this is because file path is basically when you browse and then I select my Excel sheet that I want to use right now. This is my file path with the extension and with everything. However, this node is not a file. What this node is doing is feeding that into my node here.
It's what Nuh had talked about a couple of sessions ago. This, what is the node expecting versus what is it that we're giving it? And it's a common mistake. I spend a lot of time trying to find this file from path. Like, why is it not working the first time I was importing from an Excel?
Yes, and if we run just to see what it's doing, it's just basically getting the file for us from the path. Now, the second thing is the sheet name. And if you don't know what that is, if you go to Excel, this is basically your sheet name. This is all the data that I want to put into Dynamo. So I need to tell the node which sheet to look into because sometimes you can have multiples of sheets on your Excel sheet. So it's important to know that we are now under sheet 1 and that's the data that we want to get. So we specify the name in Dynamo the same way it is in Excel. So
this also means that you can take multiple data out from this exact node and from this exact file path, and then you can just specify, oh, I want data from this path and this, or this sheet and this sheet and this sheet.
Exactly, yeah. And that's how powerful this could be actually to get it from multiples of sheets.
Yes.
Yeah. So I will double click again to write the sheet name, and my sheet name is sheet 1. And quotations again, and then make sure you write it properly the same way it's written in Excel because then it will not work. So that is my sheet name. Let me run and see what happens. I should get my data, and I have 227 index values, and that is because combining all of these cells, I have 272 cells now. That's how it's that's what it's doing basically. So before we move on, I think it's important to kind of explain what kind of data is coming out of this node, because it can be a bit confusing. Under list 0, we can see that we have all our the first row that we have here, like the row labels, a meter, width, and everything. This is everything that we're getting under list 1. So what Dynamo is doing is it's dividing the data that we have in Excel into lists. So we have list 1, and then I think the end would be 15. So we have 15 different rows, actually 16, because it starts from list 0. So we have 16 different rows.
This is fine, because when you think about what we did last time, we also added our last data into row 16. So yeah, it's perfect in that sense.
Exactly. So this is what it's doing. Dynamo gets each row individually and separates it into a different list. So then in the end, you end up with 16 lists, because we have 16 rows, as you can see from here. So we don't really need this all of this data. It's quite cool. We can play with it. But for this script exactly, we only need our SFB codes and the door type, because what we've been doing so far is we've been trying to prepare this door type column, and this is what we need. And we also, of course, need the SFB codes so that we could link the type with the SFB code and get the data that we want. So from this node, I only want the door type and the SFB code. How do we do that? That is actually super interesting, and there's different ways of getting this, but one way that we are going to introduce is index of. And the way this works, not this one, it's list index of, yeah. Make sure you use the proper node, because sometimes it gives different, Dynamo gives you different results. So under list index of, so this is my list over here. I want to get my door type. So my element that I want out of here is door type, and that's what I'm going to do. I'm going to write that in a code block. So if I double click and I write door type, and then I connect these two together and run it and see what happens. This makes sure that because we have L3, so this adds another set of levels to us. So notice what's happening now. We are getting only one value, and this is wrong. I want this to go through all of these lists and get into the sublists themselves. So going to L2 and then getting the door type from there. So what I will do in order to achieve that is going into this arrow right here, use levels, and then specifying level 2, because the default one was L3. And right now I need L2. So I will run again.
That's quite a good point, Nohad, because often when you're trying to do a script, right, and you're sorting through the different layers of list, it can be so frustrating when you're trying to look for a specific data and you know you've done it right and it's not showing it. So just go back, look at your lacing, look at your levels.
Yeah, levels and lacings, fundamentals of completing a proper script, I would say. So right now, I would like to explain what's happening here, because for some people it might not be that clear. What's happening is that this node is going through each of these lists. So I have list 0, and then I have list 1, list 2, and so on. It's going into each of these sublists, and it's looking for something called door type. Now, ideally, door type only was in my first list, door type, and the rest is just data other than door type. So I would get a value only under list 0, because that's where the door type that I specified here is. And the rest, if you notice, is -1. And -1 means that it does not exist, or it means false, basically. So we could ignore this. We don't need all the -1s. We only need the 15. We only need to know at which index is my door type, so that we can obtain the data that I will show you in the end. So in order to kind of filter this in a way where we only get the first item, we use another node called, and this one is quite cool. It's called first item. And what this does is that if you connect a list to it and then you run, it will only give you the value of the first thing in your list, basically. The first thing in my list was 15, and that's what I get. That's what I need exactly.
It's kind of like a list index of that we've just used, but only for the first item.
Exactly.
And the nice thing about Dynamo is that there is a sister node to this one called rest of items, where you show everything else that you've
we can
not
show
listed.
that actually it also comes under the same search, because they are both together kind of. So what this does is, because this one is getting the first item, the rest of items, as Alex said, would be everything except the first one. So if I run this, I will get all the -1s as my result, because they were everything
It's
else.
not relevant for our script right now, but it's they're often used in conjunction with each other.
Exactly. So right now we know at which index is our door type. What we can do is to get that data itself. And the way we are going to do it, and of course, it has to not just get it from the first list. I want to get it out of all of these lists. So out of all of these rows, I want only the door types. And if I continue, and the node to use is get index. Nope, it is get item at index. And what this is doing is from my data here, I want to get only 15. And what 15 is the index value of all of my sublists. So only the door type data.
These two nodes look really alike, right? But they're completely different. List index of and list get item at index. They're working much in a similar fashion, but doing two completely different things.
Yeah, so you need an index in order to get an item. And that's what we've been trying to do. And an index, if you're not aware of that, is these gray boxes right here. These gray boxes are index values. So 15 previously was this number here, 15, because door type was under 15. That is what an index is. So once we identify that under each of these sublists, 15 will always be the door type, then we can just get all that data.
Yeah, and in a quantity takeoff like we're doing, you're going to have loads of items, so they won't all be door types. That's the power of this, that you can sort through everything. You could make the exact same for floor types. And
definitely, yeah. And before we move on, make sure that this is also level 2, because if we go back to our list, this is also having 3 levels, which is not the usual way. The usual way is you get only L2 and L1. In the case of having L3 as an addition, we always make sure, not always, for our case right now, L2 makes sense because we wanted to go into the sublists themselves, not the main list. So if I run, let's see what it gives us in the end. It gives us the door type and everything that comes under door type. So if I go to Excel, again, just to show you what was happening, what Dynamo has here is exactly row P. So door type, and then I have null, 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 because there's nothing here, of course. And then suddenly I have all of these 4 door types, and that's what there is here. And then, of course, 3 more nulls because it was empty. So that's the whole idea. That's what Dynamo was trying to do for us in that case. So now I have my door types, and it's actually exactly the same step that I would need in order to get my SFP codes as well. So in order to save time, what I'm going to do is I'm going to select just these 4 nodes that I used because I want to repeat them. I will right-click and create group. And I will name this you could name it whatever you want, but we can just say get door types. And because we want to achieve the same thing, but instead of having the door type as our data in the end, I want SFP codes. So one way to do that is to click on your group, because we grouped it now, go to Control-C, and then Control-V, so that you can copy paste your data, and then just pull it down here, maybe this one a little bit up.
Grouping is also very important to make a sense of your script, right? Because that way you can see the text part, and then you can see, okay, I've grouped these nodes under here. This is what they're doing. That's typically how I group them anyway, by what they're doing, exactly like you've done now. Get door types. It's not necessarily what the actual nodes are doing, but it's what the end result will be.
That is entirely true, and it also makes sense when you share it with other people. When you name your groups, they will be able to understand more
much easier
what's happening in the script, especially if it's a huge script.
And if you're using package nodes and you don't really know them, and if you're using custom nodes, yeah, then
yeah,
it'll be
it
much
gets messier,
easier.
but that's gonna make it much better. So anyhow, we copied everything. What we need to do is just rename it again to get, instead of door types, we want SFP codes. And that's just naming our group. It's not doing anything to the nodes themselves. So what we need to do is the element, instead of getting door type, we will just select it and place SFB codes. And I think SFB is capital. I have to check. Yeah, just SFB with a capital. That's how it is in Excel. So make sure you write exactly what is in Excel to get the data. So once that's done, I will run again to see if I get anything here. We don't need to pin this one. And exactly, I am getting the SFB row or column, sorry, and all the SFB values. Now, what's interesting here is that, okay, I have gathered my data from Excel, and then I got my SFB codes and I got my door types. However, I don't know, or I haven't told Dynamo which door types or which data do I really want to get.
No, so we need to list them out and combine the door types with the SFB codes.
Yeah, so to know which is under which and what do we actually need in order to set the end parameters that we specified. So the way this is going to happen, the way we are going to map this data with the SFB codes is we are going to use a node called string.indexOf. This is quite the same as the index of that we used here, but this one is for strings rather than. And the interesting part about this one is that we can search for a particular thing inside of our list, but they should be strings. So make sure right now this data over here is not strings. It could be numbers. It could be so many different things depending on what your Excel has. So as we said in the last session, I think we use a node called string from object. And
this is basically converting everything that is not string already to a string.
Yes.
So if you have ID numbers in the end of it, then you definitely know it isn't a string.
So object could be actually numbers, could be IDs,
anything.
It could be so many things. So that's the cool part. So anything, whatever it is, it will always be a string in the end because this will convert it into a string. Here, I want it to be strings. I will connect it here, and then I will connect it to my strings because this is what I want to get in the end. I want to get the data out of this list. I wanted to search for, if I go down here to what Alex did, I wanted to search for my door types. So now what Alex was doing is he specified all of these door types that I have in Revit. So now I have them in Dynamo. However, what I need to do is to get them and find a way to search for them through the Excel sheet, because the order of them being placed in Excel, they are here exactly, is different than the order that they are in Dynamo. So this is where it becomes convenient, where we can match things together and proceed with our script. So for now, if I use this node, it's not very ideal because I don't really need every instance of each of my doors. So what happens is here that I have 4 instances of the same door type, and then I have 3 instances of the same door type, and then etc. for the rest. I only need 1 item of each door type in order to proceed, because this is what's happening here. I'm getting the door type, not the door instance. So I also need only one thing so that it only specifies the type. In order to do that, there's the same node that we used here, first item. We can use it again, and we will get only the first item of each of these lists so that we get 1 instance of each one. So first item and groups. Make sure it's L2 because we have sublists over here. So I will just make it L2. I will run again and see if it gives me only 4 values. Perfect, that's what I need because I have 4 different types. And the way I know that it's 4 different types is from my unique keys. There are 4 different types here.
Yeah, it's basically just a different way of getting unique lists and getting unique items that we're trying to showcase that you can, yeah.
Yeah, exactly.
Sort your lists. It's a very powerful. Often they won't contain only what you want, and you'll need to rule stuff out.
Yeah, precisely. So now I have the first items, but remember that in this node, it has to have strings. That is the rule. And these are not strings, again. These are, with IDs, these are elements. So what I need to do is I only actually want the name of them. I don't need that ID. So one cool part when you have elements like these is to use a node called element name. And Alex used this as well in the previous session. And what this one will be doing is, which is what we have here, and then it will only retrieve the name of that element instead of everything, like with the IDs, and sometimes it comes with the family types, so we don't need that.
That could be alright, yes.
Yeah, yeah. So this cleans it out in a way that you only get the name in that. So that is what's happening. I get the name, and it's strings because everything that was here, IDs, and the green part is gone. So, and my output is string, so that's even more guaranteed. So I will just input that in search for, because what I did was in my door types, I want to search only for these for door types. I don't want anything else.
And these are the ones that we manually mapped in Excel as well. Exactly.
So now I have the data. I can see where what is from Revit located in Excel and get that index. So I'll just run. And then if I pin my results, I will get 4 values. However, it should be, yeah, we missed one thing. We need to consider also the levels part, because right now I have only 4 different types, and I want this to match. So I want what I want to do is I want the first door type to be looked into all of my indexes here, and then once that's done, it will give me if it's there or not. Then it should move on to the second door type and then look again, is it existing there or is it not? And then the same thing with the rest. In order to do that, and if you were there in our previous, not the previous one, the ones before, we spoke about lacing.
Yes.
And lacing is basically, if you right click on a node and you go to lacing, you click on cross product. This is what we want. We want the matching of data to be between every single item. So every single door type should be looked into all of these items here. So I will just make sure that cross product is here. And notice now I have 4 items, but now if I run this, I will get 64 because, yeah, instead of running it only once and not having the correct values, each one is being run 16 times and then another one 16 times. So 16 into 4 is
64.
Exactly. So that's exactly what's happening.
But this is what we just said before as well. Listing or levels and lacing is the keys to getting easy and proper scripts.
Yes. And we need to try to understand again what's happening here. We are getting -1 and 0 values all the way. And what you need to know is -1 means that it's false or it's not there. 0 means that it is there. So 0 is true, -1 is false.
It's because when we're talking coding language, it's difficult to understand when you don't really think about it. 0 should be null. No, yeah. But it isn't.
The coding of Booleans mainly.
Yeah. That is so 0 is 1 when you're talking the row of numbers, and 1 means yes. So that means that we do have it. It's a bit difficult to understand, but this is how it works.
Yeah. So right now our data is not the way that we want because it's a bit scattered. What happened was that each of these, so all of these 4 values will be looked into all of these and creating sublists out of each of these door types. What I want is I want to get all the results of the first item in one sublist and then all the results of my second item in the second sublist. So in order to do that, I use a node called list transpose. And what this one is doing is it will switch the structure of my data. in the opposite direction, and I will show you what happens when I run it. Notice the difference between this list and this list. They both have 64 items, but the difference is that the first, so all the 0 values, or the values at index 0 will be under list 0. And then all the values under index 1 will be under list 1. So it's gathering the data in the way that I want it to have. So it's basically the same thing, just changing the structure into a different way, combining the proper items together. This is very convenient in many different...
In a lot of different scripts. And you want different lists for different items. When you're making big lists like what you're showing just now in the string index, like what's pinned there, that's really handy for taking a specific instance and working with that. Whereas now we've already gotten our specific instance and now we're trying to work further with it. So it depends on the levels and how far you are in what you're doing and what type of list it is that you require.
Exactly. So now that we have everything so far, what we need right now is to get rid of all the -1s, because these are the false, as we said. We only need the 0, which is the true. And in order to get that, before we get the actual value, we don't want the 0 actually, we want the index of the 0 so that we can get it from the actual data that we were using. In order to get the index, again, we use the same node that we used before, which was index of, and the list index of, make sure. And then we are going to connect our list. And what we want is 0. So I will double click to get a code block, click on 0, and then connect that 0 to my element. Make sure your list is also L2 because we have L3 here. Again, it's the same thing that's happening all over again. So that is, if I run this, exactly, I only need to get all of my zeros over here. What's happening is that Dynamo is going to each 0 and getting the index value. So I have 9, I also have 8 here, and then I have the rest over here. So I have 4 zeros and I have 4 trues, so 4 index values in the end. Now I have the index values. This is useless if I don't move on from here. I need the value itself, and in order to get the value itself, and if I remember correctly, these were my SFB codes. I want the SFB codes themselves. So now that I know which index values each of these SFB codes are, so 8, 9, 10, 11, I can zoom in and see 8, 9, 10, and 11. These are the SFB codes of my doors.
So it fits perfectly.
It does.
Lovely job.
Yeah, I mean, it's always risky, but it worked. But what happens now is that we want to get out of this list these index values. And in order to do that, it's quite repetitive as well. We are going to use get index of. And it's the same get item at index, sorry. And it's the same concept that we did before here. So we got the index and then we get the item itself at that index.
Hang on us with a moment. We're soon getting to the bread and butter of it, where we'll really see where we implement this. It's quite a lot of list handling and everything, but I promise you in a minute, everyone, you're going to be amazed.
Yes. Okay, so we have the index values. We can place them here under list get item at index, the second input of that. And then our list is the SFB codes that we have here, right? So if I run this now and see if I'm getting the proper items, the proper 4 SFB codes, that is what I want.
Lovely.
So now that I have my SFB codes and I have all the, if I go here and I have all of my elements, and just pull this out, I have all of my four door types specified here. I have all of the values that should be under each door type. I can just put that value in here and run the script. But before I run it, I want to explain one thing that is happening here. I just want to pull just these nodes so that I could zoom in a much better way. And yes, so now that we have the SFB codes and the door types, what we need to do in this final node, I have to first unfreeze it, of course, because it will not do anything otherwise. And I need to right click and go to lacing, as I mentioned before, and use longest lacing. Now, why is that so? It is because I want, what happens is that usually it shouldn't be longest lacing, but because of the case of having two parameters.
Yeah, and this is what we're doing, right? We're catching two flies with once at once. We are getting both our SFB codes and our type mark for our construction drawings and also for our quantity takeoff.
Exactly. So this is in order to make this work, and in order to get to place the values that we have here in both of these parameters, I have to specify that they are under level 2 and that the lacing is longest. That is why it is. And so I will run the script, and I want to minimize before. Actually, before I run it, we could just group things together so that it becomes less messy and we learn from the grouping part. So I will just select these nodes here, and they were used to map things together. So what we want to call them is mapping codes, or SFB codes to be more specific. Door types. So now that it's clean and it looks much better, we can just run the script. So I will just minimize again. And when I run the script, if I go to the side, yes, when I run the script, I have tags already on my doors, and these tags should change values from SFB. So from these numbers into SFB.
Yes.
So they will end up being tagged with the SFB code. So let's just run it and hope for the best. And that is what we have.
Oh, that's lovely.
We have all our doors tagged with the correct SFB code. Now, one thing before we end this session is that there might be a confusion about why, if I go to one door and then just edit type, there might be a confusion about why we added this value into both type mark and SFB code. The reason we added it to type mark is that because we wanted to use it in tags. And in order to do that, it's much easier to use type mark. You could always create a shared parameter and then just use one parameter instead of two parameters. But we wanted to create a parameter called SFB code so that, for example, if we want to schedule doors, let's create a schedule for doors just as a quick example. So new schedule and then doors, and okay. And then I want SFB codes. I want this parameter to have the SFB code name. So if I could always add type mark as my parameter, because type mark also has those values, but it's much more much better in terms of communication wise, and then you can always share this, you can always print your schedule, you can do so many things with it. So it's nice to have the proper name of SFB codes. And let's say, for example, family and type. If we just sort it by family and type and then just create a schedule, we will get all of our family and or all of our doors with the SFB code that we have added. So this also proves that the script works and that it added all of the SFB codes into all of our doors, and they should all be correct, of course, according to our matching that we did in Excel right here.
And this is useful for a variety of design phases, right? That we are getting to pricing our units, we are getting to the construction phases. When you have the SFB code as a block by itself or a column as itself, then everyone knows what you're talking about. Whereas if it was just called type mark and it had a bunch of numbers, then it was like, oh, what's that?
Exactly. And it's also the same concept as we had it in Excel in the QDO. It could be named something else, but it's obviously much better to name it the way it is. And this might not be SFB. This could be
this could be CCS, BIM7AA, everything.
So the concept stays the same. The naming part is always manual. You can always edit that, but the script is standard. It applies to all the different codes. It applies to all elements. Now, in our example, in this series, we only worked on doors.
Mm-hmm.
However, you can actually use this and choose other categories other than doors.
Choose windows, everything will be marked out with the window when you have updated your quantity takeoff SFP codes to Windows, of course. But after that, you can apply it to everything.
Exactly. And actually, in order to, if you would like to think it in more depth, the whole script, if you were able to combine all the categories that you have in your QTO. So right now we only have a few categories. This is just a basic example. It has some walls, it has some doors, and maybe some windows somewhere. But if you usually get a lot of different elements. So a smart way is to create the same script, however, adding all of these different categories and then running this in one go. And then in the end, if you minimize and go to Revit, your level, and you can just tag everything, and all the data is going to be there. So if you go and TG is shortcut for tag, if you tag your walls right now, there's nothing under it because we haven't given it any value. But if you do that in your script, then just imagine how everything will have proper SFP codes, everything could be tagged, and it's just much better.
Exactly.
Yeah. And you end up with this example that we showed you at the beginning, with everything being tagged. Not everything, but some things. And
well, I mean, there will always be stages to it, right, and levels to what your requirement are. For example, for fire plans, you want the fire tags to be there, so you'll then have your tag on your file plan to be, okay, this is the parameter, like we created before, the SFP codes, that we can tag it for what we're requiring, right? There's different levels and different implications for it, but it's very powerful in it by itself.
Definitely. So that was it for our session. We obviously have more plans ahead. We are always excited to share much more knowledge than that, but we are trying to keep it simple and short every series that we make, so that it becomes much more exciting and much more. So we add the diversity part into our sessions. And stay tuned. We are going to make some posts about what we have for the future. Follow us on LinkedIn and Teams and everywhere. I will send them in the chat while we move.
There's a lot of different things that we are wanting to do with Dynamo, and different things that we're wanting to have. Yes, please. I just see Tade. Sorry for butchering your name. But please write if you have any comments or any questions to the script and anything that we just went through. But yeah, we've got a lot of other interesting things that we want to do.
Yeah, we are planning a lot of things. Of course, there is nothing official yet, but one of the things is that we want to invite more people into our sessions. So it's not just us. So we could add some more content or just different ideas into our sessions. So we will obviously update you about that, and we will send it on Teams as a post as usual, and all the recordings as well will be sent.
If you see where we are today, we've just got a new studio for doing this as well. So there's definitely some things that we're wanting to create, right? There's things that
it's actually really exciting, because this is the first step for us to develop things and make it a bit more professional than we usually have, and make great content for you guys, because what we're trying to do is to show you how to use Dynamo in your semesters, because that way you could understand much better the benefits of having this program as a skill. Or so
it's all different stages of where, and this is things that everyone can use, right? This is applicable from first semester all the way till 7th semester. It's not necessarily a deliverable. So when you're thinking about, oh, do I really need to spend my time on this? I can promise you should, because they will make all of your other deliverables so much easier.
Exactly.
Also for the business, right? If you can come in and show this off, saying, I can cut your production time in half by this, then we have something really powerful.
Exactly.
And it's also, I think it's fun.
Yeah, it might be just us though, but I could see in the comments that Isaac wrote, it's too complex for me to jump into. I think Dynamo could actually appear to be complex, and especially if you're starting out with it, it's everything that you learn as a new skill will always be complex.
Yes.
But when you start to break it down into steps, and when you start to understand it in a much deeper manner, it becomes the complex part turns into simplicity, and everything becomes much more fun. So definitely we recommend this to everyone, all the students. Make sure to reach out to us for any ideas. We are open to that.
If you have something crazy that you've created and want to show off, then that would definitely be a thing as well.
This is the spot to show off.
Yeah. We will also try to get some more into the modeling right in Dynamo, where you can actually produce some visuals. Where, I mean, right now it's just been very much about lists, and it can seem a bit boring, even though it's very powerful.
We could add some geometry scripts and something much more fun. But it's so important to also stress the data management part.
Exactly. Like we are trying to teach ourselves BIM right, and DI is very very important in this. It's all about the information. It might seem a bit tedious, but it's important, and I think it's fun.
Yeah. All right. So let's end this session. Thank you guys so much for joining us. We're looking forward for the next sessions, and see you next time.
Thank you.
Bye.